your first Chemistry 1 AO3 or 1 EO3 experiment. Today we're going to be doing the titration of sodium hydroxide and hydrochloric acid. Before we get going, I just want to briefly talk about some of the equipment you're going to need before we get going with the experiment. The first one is your laboratory notebook. Currently this year we have two possible laboratory notebooks. There's the older copy, and if you have one of these, it's absolutely fine to use. It's a Hayden McNeil carbon copy book. We've also started going to this spiral bound notebook. It's a little bit bigger and a little bit more convenient to use. Either one of these lab notebooks is okay, and they're mandatory. The reason we use these laboratory notebooks is they have carbon copy sheets, which are easy to rip out and give to your TA when you've done the experiment. One important thing to remember about your laboratory notebook is you should be writing in it at all times. You do not put any data into your laboratory manual. You don't put it on scrap pieces of paper. All data goes directly into your laboratory notebook. It's extremely important to do that. Second thing you're going to need is a set of proper eyewear. Here we have the goggles outlined by McMaster for students to use. Any goggles are fine as long as they form a proper seal all the way around the face. You may notice your TA or the instructor is wearing glasses. These are not permitted for the students. Students must have goggles when they are working in the laboratory. You'll also notice my attire. I have a laboratory coat on. Highly recommended that you have this. What I say when you come into the lab, you should be covered from neck to wrists down to your toes. That includes closed-toed shoes. Ballerina slippers, sandals are not acceptable when you're in the lab. Okay? So please make sure you come with the appropriate attire. If you don't have the proper attire on, there's a good chance your TA may ask you to leave and you'll forfeit the mark for that experiment. What we're going to do now is actually get going on our first experiment. So what I'm going to do is, I've got a couple beakers, I've got everything set out here so far. Grab my beakers, I'm going to come up to the front of the room. You'll see we have our chemicals laid out. Today we're working with sodium hydroxide and hydrochloric acid. One of the first things I'm going to do is put on a set of gloves. You should be wearing gloves for all the experiments when you're working with chemicals. So I've got my gloves on. The only time my gloves should come off is when I start working in my notebook at the end of the experiment, or when I go to leave the lab. The reason I'm wearing gloves is to protect my hands from the chemicals and protect myself from the chemicals. If I go to walk outside the lab right now, and if I touch the door, I have now contaminated the door with all of the chemicals that I was protecting my hands from. Similarly, if I go in the hallway, I'm now contaminating the hallway and everybody out in the hallway with all the chemicals I was protecting myself from. So whenever you go to leave the lab, your gloves automatically come off. The easiest way is pull one off, wrap it in a hand. The other one goes around, straight into the garbage, and you're ready to go. You're welcome to use more than one set of gloves in an experiment. So I'm just going to take a second here, put on a second set of gloves, and I'm going to start dispensing some of my chemicals. So one thing you want to do when you go to get your chemicals is make sure you have your beakers. Normally we get our chemicals in our beakers that are in the drawer that you're going to be using. You want to make sure they're clean. So these have been pre-rinsed and dried. So I'm going to take a little bit of sodium hydroxide here. Always make sure you have an idea of how much reagent you want to use. You don't want to take too much and just waste it. There's no point in doing that. And I've got my hydrochloric acid. Really good to make sure you know which one is which. So I have these labeled as HCl, and the other one is sodium hydroxide, so now I know which one that I'm working with. Come back to my desk, and I'm going to start pipetting out some of my aliquots of hydrochloric acid. So they're going to go into our Erlenmeyer flask. So I have a pipette here. It's a 10 ml pipette. This should be cleaned. I've cleaned it before I started this experiment. The way you do that would give it a quick rinse with your sodium hydroxide, usually with the pipette bulb. I'm just going to directly pipette it now. To do that, we're going to use our pipette bulb here. It's a 3-way pipette bulb. The way you want to use it is, there's a little A at the top. You're going to depress the A at the top of the valve, push into the bulb, let go of the A. You're going to notice it forms a bit of a vacuum within this. I'm going to insert this now onto my pipette. You do not need to push this very far into the pipette. I mean a centimeter, just as long as it goes in and makes a slight seal, it's absolutely fine. The central button here, which is labeled as S, will now release the vacuum, and if we put this inside of our solution of HCl, it will begin to bring the level of the HCl up. Now what you can do is you can stop it right when it gets to the line. There's a line right here. You may not be able to see it on the camera. that becomes difficult sometimes. Preferably, the way I prefer to do it is, I like to suck the level of the HCl above the line and then just slowly remove the bulb. And now I use my finger to modulate the HCl level down to the line. This provides a lot of control. It's very easy to do. So now I have a 10 ml aliquot of my HCl. I can put it into my Erlenmeyer flask, let it go down. Now again, this Erlenmeyer flask would have been rinsed and cleaned and dried beforehand. Actually, drying is not 100% important because we're going to add water to it. It's always good to think about when it's important to keep your concentrations consistent, when you can add stuff and it's not going to make much difference. So you notice there's a little bit of HCl left in the pipette. This is calibrated to stay like that. So I'm just going to remove that. I won't try to get the rest of the HCl out. That is not part of the 10 ml calibration. And we're ready to go. So now I have my HCl. What I'm going to do now is I'm going to add a little bit of water. Okay? So this is distilled water. It comes from the front of the tap at the room, front of the room at the tap. And I'm going to add approximately 40 mils. Now it doesn't matter how much HCl I add now because I'm not changing the number of moles of HCl. I added 10 mils exactly, the number of moles are consistent. I can add in randomly how much water I want, it makes no difference because I'm going to calculate everything with respect to the original 10 milliliters of HCl that I used. So I have my solution of HCl now. What I'm going to do is, I'm going to add the indicator in. So this is phenolphthalein, a couple drops. In acidic solution, phenolphthalein is colorless. When it becomes a basic solution, it becomes pink. And that's what we're going to use as our indicator to figure out when our titration is done. So the next thing I'm going to need to do here is prep my burette with some sodium hydroxide. I'm going to take my funnel, I have my sodium hydroxide I got from the front. Make sure your tap is closed. First thing I'm going to do is I'm going to pour a little bit in. Not too much. Just get a little bit because I'm going to clean this funnel. I haven't cleaned this out yet. Now when you're working with a burette, and a lot of times when you're working at your desk, easiest thing is to have a beaker at your desk and use it as your waste beaker. Now you can just do everything at your desk. You're not running back and forth to the front of the room, going to the waste containers. So what I'm going to do is, I'm going to take this, gently swirl it, and this is going to coat the inside of my burette with a little bit of sodium hydroxide solution. And it's going to clean it out. I'm just going to add just a little bit more. Make sure you're grabbing the right solutions. So what I want to do is I'm going to actually open the valve now, and I'm going to let a little bit of the sodium hydroxide run through. That's going to clean out the spigot. Take the rest out, put it into my waste beaker. Now I have a clean burette. It does have some sodium hydroxide in it, but that's not a problem because that's what we're going to be putting in. So now I'm going to fill up my burette all the way to the top. Now you don't need to get it to the 0.0 milliliter mark because you'll be expected to read that volume anyway, but you should get it up close to the top. Definitely make sure you take the funnel out at this point. Sometimes if you leave the funnel in and you're working with that, the funnel will shake and some drops will come out and it can alter your results. I'm going to put this in. I'm actually over the line for the 0.0 mark. Get the burette nice and stable in the stand. And I'm actually going to release this just a little bit. So what I've done now is I've brought the level below the 0.0 mark. So the first thing I'm going to do is I'm going to take my reading. So this is where the titration started. When I look up at this, what you can do is you can read to one decimal place and you can estimate the second one. So I can see this is 0.025 milliliters. So I have my laboratory notebook, I record that as my initial volume. Now I'm going to start my titration. Typically, if you're right-handed, you're going to want your right hand on the control of the pipette, or the burette, sorry. And you're going to want to use your left hand to slowly swirl the solution with the hydrochloric acid so it mixes. So what I'm going to do is I'm going to slowly start adding in sodium hydroxide. You notice at the beginning you can almost add it almost a full stream. What's going to slowly happen is eventually it's going to start to go pink. And the pink color is going to become consistent. But normally, at the very beginning, you start to get a pink color. When you swirl, it goes away as the sodium hydroxide and the hydrochloric acid react together. So now, once I start seeing a pink color sticks around for a while, I'm going to slow down the titration. I'm going to start adding smaller and smaller amounts of the sodium hydroxide. Now this is when you want to be careful, because you don't want to do this too fast. Your results depend on how close you get to the equivalence point. If you end up adding in too much sodium hydroxide, it's going to appear as though you overshot, and your results are going to be thrown off quite a bit. What I'm going to do is I'm going to put in just a few drops at a time now. And I'm just about at the point now where the pink color is being consistent. So I'm really going to slow it down and have it almost going to a drop a second here. Slowly do it. And this is the point where it's really important. If you want accurate results, you want to slow this step down as much as possible. We're almost there. You'll notice that you'll get a pink color, it'll stay, and you'll add one more drop, just about there. And what happens is I actually have a half a drop hanging on the bottom of my burette. And what's going to happen is that drop, because it's hanging, is included in the calculation of how much sodium hydroxide has been added. So what I'm going to do is to get that half drop in, sometimes you might want to use a half drop to get more accurate, I'm just going to press the side of the Erlenmeyer flask to the bottom of the burette, and I'm going to rinse it down with the water. And we're not quite there, almost stayed at the pink. What I'm going to do is I'm going to try to add one more drop. We're not quite at the equivalence point yet. This becomes a little bit tricky. You want to make sure you have a nice controlled hand. One drop, give it a stir, see what happens. And there we go. I have my pink color. You want the pink to be as faint as you possibly can. You'll actually notice, you may not be able to see this with the camera, but there's the very, very, very faint pink color to this. It's barely visible, and that's exactly where you want to be. Okay? That is a good titration. I'm going to go back now and make my second reading. My second reading's at 25.40 milliliters. I would record that volume. Now I know exactly how much sodium hydroxide I've added to this titration. If I knew the volume of HCl I added, which was 10 milliliters, if I knew the concentration of HCl, I can know how many moles of HCl were in here. If I know the volume of sodium hydroxide I added, I can calculate what the concentration of our sodium hydroxide was. What you're going to do now is you're going to clean up your area. At the front of the room, we have waste fuel mix. So we can come up here. This is where we're going to put away all of our empty stuff. There's a waste container here. Normally it's easiest if you just put all your waste into the waste beaker and then bring just the waste beaker up. Make sure you look at the labels on the waste containers to make sure you're putting in the appropriate spot. Typically you want to give this out a little quick rinse with some water, and you can put it away in your drawer. So once you have all of your area cleaned up now, you can put your stuff away in your drawers. This first experiment, the goal is to calculate the unknown concentration of the sodium hydroxide. You want to show your calculations, show one sample calculation, average out your 3 trials, and you're going to want to report that concentration to your teaching assistant. The rest of the experiment is going to be, make sure again you have good sample calculations, everything's tabulated, and you're going to want to show a little bit of a discussion that's going to focus around the sources of error associated with this titration. That's it.